Hey everybody, Paul from MyTech Legion, and we're here to visit Kingston. In a minute, we're going to go inside, and we're going to show you some new exciting stuff from Kingston, so stand by.
And again, it's the slider construction, and the speeds on this one are, it comes in 32 and 64 gigabyte capacitors, and speeds are 150 on the right, read, and 70 on the write, so 150 and 70 on these, so it's, I believe it's just a tad bit faster than the previous generation.
Okay.
And but it's at a pretty good price. We should see this queued up on eTail probably in the next couple of days, 2 weeks or so. Both of these really.
And this one is a 240 160. I didn't tell the speed.
Oh yeah,
240 160. Yeah. It's pretty. It's really fast.
1 terabyte's going to come later this quarter. 512 gigabyte will be. It's actually, if you look really hard, you can find it on Amazon right now, but they're selling it at our MSRP, which is $1,750 for the 512 gigabytes, $1,750 for a 512 gigabyte on that one currently. So, and then so the terabyte, we expect that price to
Come down a little.
That's MSRP.
Yeah, it's MSRP, so we do expect that price to come down. Like everything. So yeah.
Gotta get me one of those.
You want to remove it?
Yeah. Just to get it out of your way. Thank you.
All right, so
Basically, we're doing 2 HyperX demos here. One on this side over here. To start with, this is an AMD-based machine using an A10 processor, but we're basically showing a high-end mainstream application where guys using an AMD-type machine, 32 gigabytes of memory. We're using the 10th anniversary kit, 32 gig, and showing some of what's on a trip to Rome and some of the time-lapse photography and mid-range high performance. On the other side is what the high performance really is. Okay. So this would be the top of the line rig that you find out there. So this is using a 3970 processor from n.u.c, $1,200 processor, 64 gigabytes of memory, HyperX memory. And basically and we're also, in addition to that,
how much RAM are you caching?
So what we're doing right now, so that's a good question. So we're actually running a super speed RAM disk as well. So we have a 20 gigabyte RAM cache.
Okay, so you got a 20 gig RAM cache.
So inside that RAM cache, I have this set of images. So it allows me to increase the performance overall by bringing up the applications. So basically, we took a bunch of panoramas, stitched them all together, did a bunch of performance benchmarks, showing that using this as your RAM cache, you get another increase in performance in the system. So these are the 2 main demos on the HyperX. It's still as big and fast a machine as you could possibly do. There's probably nothing other than the graphics card. There's probably nothing else you could do that could increase performance on this system. But I'm not running graphics, so I'm not doing gaming. I'm not doing rendering and things like that. So for what I'm doing for my application, this is top of the line.
Very nice.
Everybody should have one, huh? All of us should have one, right?
It pretty much destroys any SSD in terms of speed when you do RAM cache.
Well, when you're comparing it to an SSD, yes, but when you do it in conjunction with 3 SSDs and 64 gigabytes with a RAM cache combined,
is it using the SSD as a scratch disk for Photoshop?
Well, we're using scratch disk and also for loading the applications in the OS. But the actual images are loaded inside of the RAM disk itself. So you're getting best performance out of every part of the system, basically.
Not bad.
You've heard of this?
Okay.
It's basically super tiny little PC, a 4x4.
Okay.
So full powered Core i3 processor, 16 gigs of our memory running at 1600 megahertz. Okay. And then this is a prototype of our 120 gig mSATA 6 gigabit drive. And as you can see, it's up on the TV right now. Showing off the memory running at full speed 1600, 16 gigs worth. 1.8 gigahertz Core i3 3217U, all in that tiny little box. So I'm running high-def movies on Windows 8, and at the same time you can see our score, Windows score. Of course, the 2 highest numbers there would be the memory and the SSD, so we can really add some performance processors in a box.
This is the one that Intel was. They said they were last year. It was under still development. They had the next week of computing.
So this is basically where they're going with computing, right? The Haswell version that will be out next year will make it even smaller, so it's going to be down by 3 by 3s.
Yeah, the desktop world is pretty much shrinking.
Yeah, that's all it is.
A high IOPS server with SSD, but off the shelf, right? So there's a number of solutions out there. You guys, there's Oracle and n.u.c, right? And all these kind of hybrid SAN and all flash arrays. I think the issue was that they tend to scale in cost. I mean, we look at some of our competitors, we're talking hundreds of thousands of dollars, right? Essentially to deliver 1 million IOPS. So Orange came to us. We work with another company called Cynix, right? Their Hive group, which is a high performance server group. And what we did was come up with this. We built this in conjunction with the Hive group, LSI, and Kingston. And you can see there are 24 of our enterprise class E100 SSDs. And the goal was to try to hit 1 million IOPS. That's what we wanted to do. And we're able to hit 1.8 million IOPS sustained with that. And so, yeah, it's pretty fun. We're doing this. You can see we got a little BO in there. So 3 of the LSI 9265. The 9265 is just an HBA, so we're just kind of using that to connect it to the PCI Express bus. And then the software actually kind of stitches those RAID adapters together, 8 at a time. So you have 3 8 segments. And you can see 1.8 million. If, every once in a while with this, it depends on the test and when it's run. I think if we catch the drives not doing any kind of background collection, we've crossed 2 million a couple of times already.
No way.
Yeah, so it's kind of funny. We can't do it every time I look, and I'm like, oh, darn it. So there's a log file that we keep. I think this morning we had like 1.93 one time, and so it was funny. Yesterday I was at the Storage Solutions Summit, and the other just companies with their 1 million IOPS demos and come to us for 1 million IOPS. And those boxes are, again, in the hundreds of thousands of dollars. Orange, the challenge was to do this with commercial off-the-shelf product. This box, with the SSDs and everything else, they're trying to get below a cost of $50K, essentially, right? And so it's been great. They're starting to put this into production. So this was the demo server that we did this with, but now they're actually starting to put these into production, and it's great. Yeah, it's amazing what we can do with, again, just kind of off-the-shelf. We're pretty happy with it. We've lugged this thing around everywhere, it seems like, so, and it still continues to run, thankfully. Yeah. And then like I said, the other part, 7,000 megabytes per second sustained read and over 4,000 megabytes sustained write. So that's moving data in a hurry. Yeah.
Yeah, that 1.8 million is pretty.
Yeah.
Wow. Hitting the 2 mark.
Yeah, we'll see every once in a while. So here, we just dip below it, right? 1.759. If we catch it again, like I said, it was like 1.93 earlier, and so, the SSDs will always be doing a little bit of background tasks, so it depends. Yeah, that's about as slow as it gets, but I've seen it in the 1.9s a few times already. I let it run all day yesterday just to see what would happen. I checked the log files, and it got close, but yeah. And this is just FIO, basically. We're running FIO with a couple of commands. Yeah, it was. We were really happy when we hit it. And then, I don't know if you guys saw this one over here, but same kind of thing, except we did it with our HyperX SSDs. So one of the nice things, about working with SandForce is we have access to LSI, right? LSI owns SandForce now. And just like LSI helped us over there with the 1.8 million IOPS, we got kind of a preview of their PCI Express 3.0 controllers. It's the 9207 HBA. So we've got 8 drives off of each controller.
Right.
And we've got them stitched together in Windows, just in a software RAID. And you can see here, we're in the middle of our IOPS test. We'll probably top out at about 6,000 megabytes per second sequential RAID.
Yeah, you need a better reader than that. You're gonna break it soon. And that is 16 SSDs total.
Yes, 16 of our HyperX 3K SSDs.
With the LSI 9207.
Right.
The upcoming. They're not released yet.
I think they are now.
They are now.
Yeah. So for us, it's great. I think what we're trying to show again is that with off-the-shelf kind of components, right, you can build high-performance arrays. Right? You don't need necessarily, an all-flash dedicated array. It's been interesting. I think what we've been able to show is that again, a little bit of money. Obviously, 16 HyperX SSDs is not exactly inexpensive.
The next frontier for enthusiasts, essentially. I mean, with overclocking changing the way it is, because people just looking into storage and memory as the last frontier in terms of speed breaking.
Well, you know what we're starting to see SSDs really take off is in entertainment. A lot of these guys, the artists, God, everything is there's so much CG, right? Yeah, that's involved in. So really, where we're starting to see this uptake more, yes, of course, on the enthusiast side, there's some guys that'll do this. But in the entertainment industry, any of the CG artists, the rendering farms, things like that, boy, the quicker that they can get at that data, right? The quicker that data can load and render.
Yeah, definitely.
A lot of times that is storage bound, right? You can have the greatest CPUs in the world, a couple of them, a ton of RAM and all of that, which is great, especially if it's Kingston RAM. But at the same time, right? We all know your computer is gonna default to the slowest thing in the chain.
Yeah, definitely.
That spinning hard drive, you can rate a bunch of those and still not come up with what one SSD can do. So 16 SSDs, you can have a little bit of fun with that. Yeah.
Definitely. I learned that hard way. I was recording 3D videos for gameplay videos, so 1080p in 2x2 size. So I was recording. It was fine. I was running a 3960X with 32 gigs of RAM, and of course a mechanical drive I had a separate mechanical drive for storage because I thought I need gigabytes of these. But but when I played back the video, it was choppy as hell.
Nice.
Until I was like cursing. I tried multiple programs. I thought it was Fraps and all something else, but I popped in an SSD there. Problem fixed.
It cleans right up. Right.
And that's only 100. I mean, it wasn't even it was like a Gen 1 SATA 3, so that wasn't even like 250. Imagine what 6.
Oh, exactly. And I'm only playing one video here, but while this iometer test is going on, I'm streaming this video off the same array. Right?
Yeah.
There's no.
It's not.
There's no jitter at all.
It's wonderful.
Yeah. To me, it's funny. I mean, I grew up.
Like high up there. I'm assuming you're cutting some stuff out.
Yes.
Yeah. It'll be